What do we have here? Our brand shiny new China remote control. Man, even in a wood box. Oh boy. There's our remote control with an antenna that goes somewhere. Or it might be for the receiver side of things. But what I went ahead and got here was a 4-channel servo remote control. Kind of first look here at what we got. These will hook with some linkage to the handles, and the linkage is hopefully here as well. And then we have a 5th actuator for the throttle here, and that's what that little dial on the remote does. That lets you adjust the throttle. And then you have something. Power signal. Cool. What's up, Pete? These things are pretty big. Hopefully we can mount them in there appropriately. See if we can get it all working. Nothing rickety to see here at all. Let's see if we can give it a test drive. All right, so that's on. Gotta hit the old power button, maybe? Or the stop click. How do we drive? There we go. So that's all the travel we have. Kind of thought we would have more. Oh. There's a lot more that way. Pretty powerful, actually. So it's like you have to, if you have this remote switch off, you can run it from the cab. But then as soon as you push this remote switch button, you have to hit a stick and then it will come back to the center. That's cool. And then you have a fast and slow mode. I don't know that I really like the slow. I think you basically want it to respond to what you're doing. I don't know why they come down so much more than they go up. If you hit the E-stop, it will just let it fall, so that will allow the crane to take itself back to stop, I think. I think it's going to do remote control things. Sweet! I'm curious to lift the hood up here and see what we got. A lot of weight in that. Uh-oh. And there's a screw in there now. Fortunately, the power's off. I thought they were captive. All right. Maybe these screws here are like your high and low limit. I bet they are. Or they can really stack the channels in here for you. I think the throttle is just the same as everything else. Oh, that's why it had that rubber, so they can hold these down. So I don't know enough to really tell you, but basically this is some sort of a servo driver. I assume that these guys will allow you to change the limits of them. Contact. So over here, these are your relays that run like the starter. Let's grab a little screwdriver. I mean, why find any instructions when we could just start turning screws? Oh yeah, that's how far it'll go that way. Okay. We can get a lot of travel out of her. And that's this side, I see. Oh, money. I like that. So yeah, we can get some serious travel out of this thing. So I guess we're gonna, once this is hooked up, we'll have to set these so that it's not just binding against itself, that it's actually stopping just shy of full travel on the sticks. You can see how much difference that made. Alrighty, I'm going to bed. Check this out. Woo-wee! Sweet. So I've got the door working properly. I didn't film that because I didn't think it was going to be any big deal, and it turned into a project like everything. Basically, this catch was on backwards, but I also had to do a little hammering to get it bent in and out, and hammered on that. The hinge over here, this hinge down here, I don't know if it was wrecked or you can see the door's been hit here at some point in time, but it was all smashed up. Took it off, blacksmithed it back to being flat, which basically let the door go up because it was sagging too low to get it to catch. And that fixed that issue. So now we have a working door and we no longer need our bungee cord. So that's sweet. I wanted to keep the door on because this thing's gonna live outside, and when we put the remote control kit in, I want it to stay all dry and everything as we can. So I figured to get in this thing and drive it around, the door's kind of annoying. It'd be nice without the door, but you're not gonna be in there while you're doing crane stuff. You're gonna be using your remote control. So it'll work. Next couple little things to tackle back here. I noticed the valve cover gasket's kind of like popping out of here, and when I was putting oil in, oil was coming out because of that. So I got a new valve cover gasket. Let's pop this off and change that out. Now it looks like the guy, I found it interesting, this is like sticky backed on one side, so popping out of there must be some sort of an issue. When I was pressure washing, I tried to wash where the valve cover meets the head somewhat decent, but I swear no matter how hard you try to clean something up with a pressure washer, you get it back in the shop and you see the 9,000 missed spots. But you can see down here, it's a lot cleaner than it used to be. So we'll take it. And also, I was wondering how much water got in here while we were pressure washing, if the gasket's all screwed up. Yeah, decent amount. There might be time to change the oil again. Definitely a little water in here. Need to run it a little longer. All in all, it's nice and clean though. Might help to run the valves by the look of it. Because that is pretty, I guess it's not that bad. See if we can find the specs online. Get her cleaned up a little bit here. Try not to dump a bunch of dirt in there or anything. Ewy! Definitely some gunk. And you can see why the gasket was letting some water in. I think they ran the sticky side on the valve cover, which makes sense because then you can clean it out here nice and easily. It was all happy except for there and there. We'll get her fixed up. All that nice, yummy, watery oil mixture stuff. Didn't realize how much water we were getting in here, but at the same rate, we had to clean around this to be able to take it apart. Well, that looks a lot better. Get her cleaned up here just a fuzz. Just check this thing out once. So that's gonna go just like that. I think we're just gonna pull the sticky back off and just stick it right on the valve cover here. Not use anything on the other side, on the bottom side to the head, because we wanna be able to take it back off and hopefully not need a new gasket at that point in time. I think should be how this thing goes. Well, we probably don't wanna stick it on there until we're ready to bolt it down and be able to clamp it good and tight for it all to dry. So let's see if we can adjust the valves. Let's go ahead and warm this thing up a little bit so we can set the valves warm. You can see the oil starting to come out of the rockers there. That's kind of in the cold, how long it takes to start lubing the top side of the engine. Alrighty guys, so that's how you adjust the valves with the engine running. Basically you can just feel when the feeler gauge is tight the whole way through or when you can easily still slide it through. These are odd. I've never seen rockers like this where there's no jam nut. You just turn it and basically, I don't know if they made a poor thread or something. It's basically like a lock nut. And you can just basically force them where you want them to go. I'm ready to put her back together. Stick our handy dandy gasket on here. That is not sticky at all. It's also not quite lined up there. Does it have to go this way? Yes. It's like they do want you to stick it to the head. I thought it was symmetrical. My. Get her cleaned up on the head. I don't think that would stick to it no matter what. Guess we'll just have to RTV it back to the valve cover the way they did it. Might be an after Thanksgiving lunch problem. All right, let's apply a little bit of blue goo to the situation. Basically, we just wanted to hold that gasket on there for us more than anything. We don't need to go hog wild on this. All right, that's on there where it goes. Slap her on. They have this little O-ring deal below the washer. I thought that was cool. So as the bolt's compressing that, it seals against the bolt and the valve cover at the same time. That one stayed in. Look up in here and make sure that that gasket is okay, which it appears to be. It didn't move or leave. I really like how that gasket's just flat on flat. There's no groove or anything to help it out staying where it needs to stay. Like as you tighten this, you can see it. It's like squishing out of there. So I don't think you want it very tight. Or you at least would have to let the RTV kind of set up before you tighten it much. I'm just going to very easily snug that on there for now. And then once it sets up a little better, we can probably smush on her a little more if we need to. I don't know, we really need much. See how she holds up? All right, guys. So we're back on to our remote control mission. I kind of have this bench laid out right now, just trying to figure out some of the details. Part of the problem with buying the cheapest remote control that you can find is the instructions are very limited. In fact, the instructions they gave me seem to be these printed on a piece of paper on the outside of the main electrical enclosure, so the first time it rains on this, those are going to be deleted. Might want to take a picture for future reference. But basically, what I'm hashing out here is how the ignition and starter wires work. And by careful evaluation of our beepy beeps with our meter here, when everything's off, you will see that the startup, which is actually the ignition, it's connected. If you push the e-stop, that shuts off. So as soon as everything's turned on, if the e-stop's released, it's like turning the key on. Now if we hit our remote on button, which enables the servos, we can hit the starter button here, and the ignition stays on while the starter's on. We hit the e-stop, or if you hit, they call it the flame out button, you can hear it, it dies, so that shuts it off. But as soon as you let off of that button, the ignition's back on. So I think pushing the e-stop, and that's like a key off, that's the better way to go about it. As soon as we reset the key stop, ignition's back on, and we can hit the startup button. The servos still won't work until you cycle this remote switch, I've noticed. So you have to cycle that. Then you have control of the servos and the hydraulics. The starter wires are these yellow wires, and they're just open until you hit the starter button. So that's just cranking the key over to actually start the engine. So I was trying to figure out what is like the safest, most effective way to wire this. And what I'm thinking I'm gonna do is take a hot wire in that's going to the key switch, basically your battery feed. Run that through a normally closed contact of an e-stop that's in the cab. And I was also thinking it might not be a bad idea to almost end up with like a cable. Like, I don't know if you guys have seen some machine tools, they put like a grab cable. If you pull it anywhere, it pulls on the end of the e-stop and it activates that, kills it. What I'm thinking of doing is at least put an e-stop in the cab that will be a normally closed contact that feeds the power to both the ignition and the starter. That way, if you hit that e-stop, there's no power going to the ignition, because what I'm planning on doing is wiring in parallel with the key switch. So my fear is if something were to go awry, the hydraulics want to stay on, whatever, and you can't even key it off. The key switch is going to be basically invalid if we wire in parallel with it. You can shut the key off, it'll still run if this is telling it to run. So by putting an e-stop with a normally closed contact, slap that e-stop, it'll kill the power regardless of what the key is doing. It'll kill the power to this and the key. That way, either way, that e-stop will shut the machine off. So that's what I'm thinking will probably be the most effective way to do this. Otherwise, we could wire after the key, but then you would have to turn the key on and the ignition would already be on. So I don't love that. I like the idea of hitting the e-stop on this remote, and now the power is off to the ignition of the crane. The only things that'll be powered up are the box, like it is right now, and the remote control. So I think that's gonna be our most battery effective method, because I want this to be able to sit here, not drain the machine's battery while we're over here working on something, start it back up, do what we wanna do. That's my goal, and that's the plan. Let's see if we can make it happen. So our next problem, as you would say, is how are we gonna mount these servos to the dash, make some linkage happen and all that jazz. So I'm not sure. We're probably gonna have to delete some upper dash items here, like the heater fan we're never gonna run. And the LMI might have to relocate. Let's just see what fits the best. I'll even move the shifter if we have to. I hope we don't have to, but I bought this thing wanting to make it remote control, and one way or another, it's going to be remote control. So if these levers are up here and they're moving like this, the problem is this lever is moving in and out. So it's really like the lower that this could be, the lever, the better. The more direct action you would have on that. And then these guys are way up in the air. So if this was to go in, it's going to make that very difficult to do. So that's not great. If this plate was off here, we have a little bit of room available. All the lines, these are the spool valves directly right here, and all the lines are right there. We could end up with a lever coming down off this way, but I also don't want to have absolutely no leg room and smash your knees off of these things as you get in and out. This is potentially the best I can come up with here, is actually if this was here operating in this wheelhouse, the lever could go like that. It's really, I mean, no, it's not ideal for your knees, but we don't need this thing to be comfortable for driving across the country. Probably the higher it is, the better for your knees' sake. Just say it was over here. You got to get your foot on the gas. We might have to give this thing the Peterbilt seat package to get you down and away a little bit more. No air in the seat, please. That comes back. You got to have above the fulcrum available So that really needs to be down lower, as that would go. You'd hook from here to here. And that does not leave you much legroom. So from what I can tell, I think our best bet is to basically make a plate that comes straight off at this angle, coming up right in this vector, and then we're going to connect this and this. Now, unfortunately, this is definitely in the wheelhouse of in the way for your knee. And driving with the door shut is going to be just about impossible. But I don't know that there's a better option, because up here seems pretty much impossible. And I think literally worst case, I will lower the seat down and make this thing ride like a Peterbilt with no air in it, if that's what it takes. It is what it is, and now being comfortable in the cab really isn't going to be that important. Being able to use the remote control, to me, is the important part. So let's start doing a little measuring for this plate we're going to have to make. Let's call it 11 inches from the bottom there to that mount. That'll put it right there. We'll probably just end up drawing this all up in SolidWorks. So if we just burn out a flat plate for both of these here, these 4 holes that it's going to need to bolt these down, and then we'll do some sort of a stabilizer, probably just one, like off of this bolt here would be just Jim Dandy. Catch this bolt, back our way out to the plate, give a little extra support. If we make this bolt on and that, catch that bolt there, we can easily remove the tie rods, pull this all out of here if it proves to be A, a terrible idea, or B, we really don't want to use a remote for an extended period of time and we want the increased knee room package. All right, so to do some really high-tech fab work here, 5 inches straight out meets at 11 here. So we'll have our plate come up, little tab come in there. So as far as the width of this plate goes, for this guy to line up here, it's going to be about there. And then we're going to just double these up, so that's going to end up here. The thing I'm concerned of is having enough for that to catch it. So if we put a little bit bigger foot on there so that it slides this over, our support leg, we'll catch that bolt, move over maybe an inch, come over somewhere here. That way we can just butt up against the back of that where it lands. And it should be just fine. So I've been doing a little bit of laying out for how exactly we're going to mount this servo. And this is what I've come up with. We have just a flat plate. These 4 holes will be the servo. They're kind of offset to the one side because that's how the servos are made. And these 3 holes will catch down at the bottom on the crane. I'm going to cut this first one out of just 1/2 inch thick HDPE plastic on our CNC router because that's what I have the most readily available. We don't have our own burn table in-house. So I'm going to cut these out on plastic, see if they'll work, and then I'll order the steel. If we have to make any modifications, I can easily drill this, modify it from there, and then change my drawing and order up the steel plates. So we programmed this upstairs in my office. I'm going to get the machine loaded. It's still firing up. Got a little chunk of plastic here. I'm going to cut these 2 brackets out. So this is a vacuum table. It holds the parts down by pulling a vacuum through this MDF, and basically the weight of the air above this just holds this thing down. The vacuum is down in the basement, and we have a 4-inch piece of conduit that runs up, over, and down into the basement because it is very loud, and we like to keep that noise down there. Give her the beans. So the first thing it's going to do is drill all the holes. These are our 2 plates. I leave like a little thin layer. We leave that down there so they don't jump out. The small parts don't hold the vacuum very well, so we take a little hand router. It just traces this with a tracer bit. Cut them out. Let's see if it works. In the same way, we don't drill these holes all the way through. There's just a wee little bit here because then we would hit the table every time, and we try not to do that. Forgot these need to be this size. The bolts they had. These are gonna go that way. I originally had that the other way and I decided I was wrong. And I threw them away and they're in the garbage can at work. This is why we make templates. Looks like our length is a little bit off there as well. Now, I don't plan on staying with 1/2 inch thick HDPE. That's why these bolts are barely going to catch. For what we're doing, it's going to work. Alrighty, let's see what she looks like on the T-Rex. That's our pilot. Will this thing work at all? So you can see right there, we can cheat this. We could use a little bit of that room. Not a lot of it though. Boy, getting in and out. That's gonna be not very fun. Maybe being up higher. If it was up this way, it would be a little more out of the way of your knees. I think this is the best of the options we have, because if we go up here, it's not a good angle with the way the lever moves this way. We got the shifter we gotta move. We got a heater fan. I think this is kind of the least of the evils, unfortunately. I think maybe the Peterbilt low seat package is gonna have to kick in. The other thing I'm gonna have to check is like pulling this little bolt and reorienting this lever, because right now it thinks that 0 is here. And I don't think anything stops it from traveling there, but we're gonna have to basically rehome it that 0 we want to be here. 9 degrees off, so maybe there's a chance they drilled multiple holes through the shaft. Let's see what we can find. Well, the bad news is they drilled and tapped a hole through this shaft, and what that means is there's no easy way to reorient that. Kind of stuck there. What I'm going to do is pop the side cover off, because I'm curious, what do we have behind here? Can we just kind of retime something, even with the potentiometer, giving it the feedback? Whatever. Let's see what we got. So we have 3 wires and a board. That has got to be the position feedback. But these 4 inner screws were actually connected directly to that piece. I bet it would come out if that lever was off. I'm gonna have to take these two apart from each other. You can't get there from here. So if we take this little lever off here, will that allow this? Yep, that can come out of there now. That is your gigantic potentiometer, I guess. And then we have a plastic worm gear drive right there from this motor. Interesting. If that's the feedback directly on there, it doesn't matter how you put this gear in there. You're not losing any time, because this potentiometer is just going to turn itself until it's happy. How can we recalibrate zero then? There's got to be a way. There's got to be. We might be drilling another hole in that shaft after all. I guess I'll tear into that control box a little bit harder and see if there's any adjustment on center. I don't think there was. There's a screw for max travel each way, but I don't think anything there changed the center position. So I don't know what we're going to do there. So looking at this, we have a couple snap rings holding this whole ordeal together. Now turning this a million times could make this angry. The first time it's powered up, it's probably going to seek however many turns back to get to the middle. The way I know this works on like a little RC servo is this potentiometer in here is just a variable voltage, say 0 to 5 volts. Oh, they're only on one turn though, which may be how this works. It might just be a one-turn pot. So it'll just seek its way back to where it was. What we need to do is just clock where the shaft is versus where the potentiometer thinks it is 90 degrees, and that'll do what we want over there. So I don't know if this is like splined together or if it's just a press fit or what exactly is holding the alignment. But there's one way to find out. Shimmy shim shim there. It's kind of tight on that inner bearing race, it seems. Don't think we want to go hammering on it. If we take this outer snap ring out, that lets the bearing come out this way. I don't think that really helps the cause much. Put like a pulley puller on here and push on that, what kind of destruction we are going to cause doing that. I have barely used this puller set. The one Mrs. Puff got me for Christmas a couple years ago. We're gonna get it or destroy it trying at this rate. And we're still free. Not free. It's going with some major destruction. So in order to get this thing moved 90 degrees off, and I destroyed the servo trying to take that apart and change the potentiometer, I'm going to drill it in the drill press here and see if we can change the angle that way. I'm just drilling a hole. Yeah, I thought it sounded good. We got clearance. Got her cut up like Swiss cheese. All right, let's try the modified Rooney lever package to get this one out of the way. Because I'd like to get this all hooked up in this temporary C-clamped kind of manner. You can already see the HDPE is warping from all this weight on it, so that's definitely not our long-term solution, but it's more of a mock-up kind of thing. He got that so that's the way it was happy. And that's gonna come up here, and then we find where that'll thread in. I think we're definitely gonna want some Loctite in the final rendition here. So that should put us centered like that right there. Let's plug it in some power. Let's get her fired up. Just cycle this button here. Oh, I guess I plugged in the wrong one. Whoopsies. Sweet, now it's centered where we want it to be. I guess what we can do is take a tape measure here, and let's just assume we put the ball joint here. That's 8 inches. So 8 inches would be the top hole. And 8 inches is the top hole. So let's see if we can hook our linkage up from here to here. Also, as soon as you let off the switch, that's what that electric clutch allows this to move. And then when you get back on it, it engages and just goes. So that's pretty cool. That should have enough force for what we're doing with this rickety setup for the time being. I think if we mount this down here and use the lower hole of the control arms, it may work better. That'll also give us a little more freedom of adjustment there. Seems odd, these are both right-handed threads, so you can't just shorten it up the easy way. And I guess what we're going to do is just put this pin in that threaded hole. Seems kind of odd. Alright, will it work at all? Oh, it's moving stuff. But it is acting as a remote control right now. Baby steps. If this wasn't flexing like no other, it would help. That is gonna work. Oh. So we're going to have to adjust our end limits, and also this is backwards. That should be, well, it says right turn, but I think that these should mimic exactly which way the levers go, which both of these are backwards at this rate. Worst case, we'll take the controller apart and flip these over. But I need to adjust the end limit stops on that one to increase them and reduce them on that one. I had to move these up to the end point as they were hitting the gearbox when it came backwards. So that's all the further that guy needs to go. If this was more rigid, I don't think this would hit the motor. And that's all the way up there to punching through the gauge. Might have to do a little more adjusting. But I guess we're ready to try this. We have a swing and hoist hooked up for remote control. I'm going to be right here near the key, so if anything terrible happens, we'll just shut it off. I'm definitely a little nervous about something going awry. I've tried the e-stop a few times and I can hold this in, hit the e-stop, it snaps right back up, so that's a good thing. Reset the e-stop, and then you cycle power here on the controller and that comes back. I'm gonna stay right there with the kill switch in case anything goes wrong, we can just kill it. It's a little rough right now, but actually the controls function really well. See how we can bring this in there nice and easy. Have a lot of fine control on it. Seems like she's a go. Let's see if we hit the E-stop here. Just kills it. And you gotta cycle this. That is so cool. Now we actually have to draw our correct brackets up and make this thing function properly. So we're back over here. I've taken the rickety thing apart a little bit. I'm trying to figure out how to make any amount of leg room because right now this is definitely not great. And what I think we can do, I'll put these back down here to show you what I've come up with. Our problem right now is when these come to the far end of the spectrum over here, this is just about hitting. But I think to overcome that, I can bend this all thread and end up with like a C shape just to give more clearance here and here. Clearance. That'll kick this guy up a little bit here. Same thing we'll do there. So if we end up heating, we'll probably heat this and bend it just so we don't cause any cracking or issues. I think that'll work. And then what that'll, like right now this is working, but what I'd like to do is raise this up, like make this bracket longer. If I move this, and we can get a glimpse of. That's 1.5 inches longer than we were, say. And it's definitely got more legroom, not great legroom, but more legroom. And this is kind of centered off of this part of the lever. So I'm looking at it here, and those wires are preventing me from, and the C-clamp are preventing me from closing the door right now. But It's terrible, but you can do it. And on this side, the motor is pretty much in line there, so you can keep this knee for the throttle. It can just stay to the left of it and hit the brake with that right foot. So that's doable. And you can have the doors shut and you can drive this thing. Another thought my dad and Big John mentioned was using a micro control cable, like a push-pull cable. And that's definitely a possibility, but I don't know how it would really improve our game here. And I think it would add a lot of complexity, because the problem is you can't really put that up here either. And I think because this goes so far, you know, the plane of what's moving is like this. So that's not going to be easy to do that. Coming down here, it's going to be like lifting up on the lever. So you'd almost be in the same situation down here. The only way I could see a push-pull cable being helpful would be to attach here and here and run down with a lever and let the push-pull cables run in and out from the bottom. That would certainly be achievable. And then we would have to mount all these servos somewhere else. So then that creates that whole aspect. So it's an option. I don't know that I want to pursue it. I think this is kind of the easier route. Yeah, it's in the way of your knees, but it is what it is. We'll stumble in here, hopefully not smash our knees, and get this thing moved around. Alrighty. Let's get this thing moved over to this trial area. I got rid of our windshield washer fluid. I don't see it being too needed. So this is an interesting thing I just now am noticing is I think first gear is going to be off limits. Hopefully it can go up the hill in the driveway and stuff in second gear. I think that's what I was using. Third gear was a no-go. So to have this here, your knee is more or less going to be wedged underneath it. I think you'll be all right. This is definitely a give and take kind of operation, as tiny as this cab is. The next thing I want to look at is where we're going to mount that remote control box. I'm thinking it's going to kind of have to build a bracket to get it up over this overload. I set the LMI over on this side. I think that might be how it has to go. Alright, so we got this guy. Obviously all the plugs have to go into it. The lid's going to set it back a hair. We also have the antenna. I may need to get a longer bulkhead antenna extension. We could put this out on the outside. Even if it was right over here on the outside of the cab, would probably help its cause. Or up high here, somewhere up here. We could put this upside down. Let them plug into the top. If it was like that, actually wouldn't be too bad. Weld a stud over here to catch that. But then the cables are kind of loop out of there, so maybe we'll turn this sideways. There's just no room in this little cab. So the next step on the receiver installation, I'm going to work on wiring the ignition, start, stop, and the starter in from the remote control receiver to our actual crane switch. Right now I have ordered the stainless steel brackets. They're going to mount the servos permanently. After using those plastic mock-ups, kind of verified everything. Made a few changes, added 1.5 inches to kind of get it up above our knees. Try to make a little more leg room, make it not so bad. But I ordered those. Guy down the road has a laser out behind his house. He's going to cut them up for me, bend them. We should have them for the weekend to get the servos mounted. But for now, let's wire up the ignition. So to get to the back of this, I think what I want to do is just take this whole dash pod back out of there again. I also think the best way to mount this is to go right in here, the way we were before. Let's see how long the connectors are plugged into there. So I've ripped the shifter back off, taken this right-hand instrument cluster out so we can get down in there the back of the ignition switch. Just kind of trying to check things out right now. Well, these mud daubers, they'll build a nest anywhere, won't they? So there's the main incoming power coming to the switch from the battery. What I'm going to do is throw an e-stop on there with a normally closed contact and then power this and the ignition switch from that. That way, to basically be a master switch, kill this thing at the end of the day, we'll just slap that E-stop. That'll kill all the power to this. It'll also take the power out that's going through the relays in this to the ignition and the starter circuits. That way, if we hit the E-stop in the machine here, no matter what that remote decides to do, it's going to shut off at the very least. That way, if the servos are going nuts, whatever, we'll kill the power. I feel it's safer than relying on just the E-stop on the remote. Now, I don't know yet if I put that one E-stop in here somewhere, might end up, like say up here, where you could easily slap it from the outside. It probably wouldn't be a bad idea to put one external on the machine as well. That way, if you're working around here somewhere, something goes wrong, you can run over and smack it. I don't know. I hope that we don't get into the situation where we need something like that, but I just would rather have something than nothing, because if we take the power before the ignition switch and give it to this thing, it's going to more or less override that. So if something's not going the way you want it to, you run over and shut the ignition switch off, too bad, it's not going to shut off. So we need some way to override our cheapest remote control available box. Hey guys, so we're back in action. Got us some sweet servo brackets. I think I still need to do a little minor modifications. I think I made the flanges go down a little bit too far. No big deal. Take the grinder, nip that off. That way this can go down just a fuzz. Servos will mount on the back just like our plate was, and we'll hook them up. I just converted kind of our mock-up in plastic. I had to add that 1.5 inch length. I had these holes offset the wrong way. Fixed that. I made these couple little plates here to mount this receiver box. My plan for this is we'll take this back apart, but this bottom plate will screw down first, and then this intermediate plate will screw on top of that plate. That way we needed this little bit of a riser to get over the steering column here and clear that, as well as I'm using this to cover up that hole from the vent. So knocking out a couple of birds with that one. Totally forgot about bringing an E-stop home. I guess this can be an E-stop for the time being. That's where we're at this point in time. I'm going to start by wiring in everything we need to do here, because these servo brackets, as we know, are going to be conveniently in the way. So let's do as much as we can before we are smashing our knees off of these for the rest of eternity. These windows are driving me nuts. I think this will be a lot better. So let's see which contact on the ignition switch is our power at all times. So the left guy has power all the time. So what I want to do is take the one that has power all the time, use that to run this. My goal is to leave the remote powered on only with the key off. That way we're not draining the battery, putting power to the coil, anything like that, because the remote will stop having the key on by just pushing in the E-stop. So that's my plan. We're going to try it. So you may be wondering, how much power does this thing draw? No idea. What I can tell you is we're going to find out if the little circuit breaker works coming to the ignition switch, because that's why they're there. This separate box, this guy here converts the 12 volt of the system to 24 volt for our servo. They only make these apparently in 24 volt from this company. I'm going to mount this up underneath the dash. I'm going to switch the 12 volt side. It'd be less current, of course, to switch the 24 volt side, but then this guy would be powered all the time. Not sure if that's going to be a voltage draw on our battery, so we're just going to run from the always hot power through this switch to the 12 to 24 volt converter. From that up to here, we're also going to grab power from the back side of this switch to go through power harness here. We have the ignition and the starter relays, basically the common of those two. We're going to grab that off the back side. That way if something's going wrong, if we kill this switch, not only is it going to kill power to the remote box, it's also going to kill the power to the contact of both the ignition and the starter coil, effectively making this an emergency stop. Alrighty, let's go ahead and drill the holes to hold our converter. Alrighty. The old 4 to 20 converter package is mounted. So what we have here are the power to the 24-volt converter, the power to the relay for the starter, and the relay for the ignition. I'm going to tie all of them together, crimp on a connector so we can connect them to our main power on-off switch. Then we're going to run power on the other side of that switch over to hot continuous power. Just going to use a big one here to catch all 3 of these wires. Give her the old tug test, and they're good to go. We'll heat shrink that for a little additional strain relief package. Then the only other 2 connections we have under here behind the dash are the starter and ignition wires, which I'm just planning on connecting right on the back of the starter switch. Basically just run right in parallel, mimic exactly what the key switch is doing. Moment of truth. So we turn this on, the ignition is on by default. We turn our remote on, then the ignition turns off when it sees the e-stop. Not loving that, but it works. It's on, hit the e-stop, it turns off. Release the e-stop, you can see the gauges and everything click on. If we hit the starter button, let's try and, oh yeah, I have the shifter unplugged. Let's plug the shifter in and see if that works. I'm gonna hit the e-stop, powers it off. Seeing this shifter in neutral should make it happy. Let's see if we can hit the starter. I'm going to give her some propane. First remote start coming up, hopefully. And we can kill it. I like it. So if I put it in gear, I want to see if it won't start. Let's make sure it... We'll put that gear shift in neutral. I think it won't allow it to start though. Sweet, it won't. Put that back in neutral. We still have neutral start safety. All good things. So this cover was here behind the tire, and this is our throttle pedal. I'm working on how we're going to control that with our throttle actuator. I think if we have a little bit of cable here, this pulls this way to throttle up. I'm thinking we can build a spacer over here for our actuator to mount on. Let that cable take up the slack, so when you manually hit the throttle with your foot, it just kind of pushes on that cable, no big deal. And then the actuator can pull on that to pull on it electronically for us to control it with the remote control. So let's go ahead and start figuring out a solution. This cable was provided. We don't really need all this microcontrol because I'm hoping we can mount the actuator right there beside it. But I think I'm going to use the cable. So these just unscrew, slip that whole cable out of the sleeve here, and we'll just cut it down, use what we need to connect one end to the actuator and the other end to the throttle. So if we can pin this in here, may have to drill another hole on that guy. Yeah, that'll work. If we can hook that there and run the actuator kind of across here. I just want that cable so like as this thing pulls some slop out, mount it like that. I just need to loosen this, flip that around, put the actuator in there like this. We just need to build some sort of a mount, or as long as we can get it in there, we could mount this off the cover that goes here. It's probably making the least amount of work for ourselves. As long as we can put it together. So I took this cable apart. Now we're down to just this little bit of extra chunks. I'm gonna pin this guy on here. So that's our throttle there. I think that'll work. This guy I'll pin on right here. It'll be stuck to that. So we're kind of along, sticking too far back here. Shorten up this little cable. I think I also may just chop this bracket off and drill another hole because we are fighting for space. So if we have this bracket here for our actuator, stick it like that somehow. Figure out how to make this work. So this guy, that's our, basically our clearance line would be here, would be lined up center. If we move this in, keep it right about there, I think that's gonna work for us. So let's get that marked out. Gave her a quick little pressure wash in there. See if we can get this marked out where we need to drill some holes. Let's tighten her up. Alrighty, that's that. I'll put that in there. Probably try to offset that. Yeah, we have that slot. Let's gain ourselves a little more clearance. See what that gap does. That's more better. I mean, how could you not use these quality wrenches they sent in this kit? So now I'm gonna cut this. I guess first we'll drill a hole, cut this. If we can pin it on first and then, I don't know what we have going on here. Trap that behind that. This must be the only length they had, so we spaced it with a knut. That'll save us some real estate on this pull length. So I got our pin here. This is what's hooking up the throttle to the little plate where the pedal pushes on. When this pulls, I don't even think it pulls the throttle pedal in. I think they're kind of disconnected, but we'll see how that goes. This is gonna be kind of a pain, but it is what it is. There. It's kind of pinched there. We're going to have to figure out, right, Yogi, how we get this actually to that box. I think we can kind of run up behind this panel here. Let's plug this into our receiver box up there, kind of in a temporary fashion. See if we have a throttle movement. So basically, I have it plugged in. Should be doing stuff, but I don't think it is. I can't really tell what's going on. It's like an inspection cover cut in this thing. Doesn't seem like it's doing anything. I know it worked when we bench tested it before. What happened? Pop the top here and see if we can see any reason it would be mad. I don't know if I've run the throttle without having any servos hooked up, but I doubt that's an issue. Yeah, none of those lights are lit up right now. Is that the e-stop doing that? There used to be red lights that would come on these servo drivers. I don't know if the throttle one here is different. I wonder why it's blinking like that. Something is not happy. Okay. I forgot about the cycle the remote switch button procedure. That's what lights up all those lights. Whoopsies. Operator error. Yeah, let's try to actually fire it up and see what it does. Ooh, a little touchy. Hey, that's what it's supposed to do. Nailed it. Perfect. We can drill a hole through the bottom here. That allows us to pass the wiring up through to the top. We have our handy dandy step bit. Be able to make plenty big enough hole to pass this wire through. As far as any strain relief goes, I'm not too concerned. Wherever this passes through, we'll put a little bit of loom just to protect the wire from the steel. I don't want to unwire the servo, and you really can't. I think it's molded in there, so there's really no easier way to make this smaller. I'll just put a nice little cord grip, really would be the best way to deal with it. So this will work. We'll pass through and this will all be relatively protected. I've got to watch, there's some hydraulic hoses on the inside, but if I stay this way, we're pretty much A-okay. Right in here, seems to be clear. All right, punch through, put her in granny low. There we go. Debugger. What do you think, Yogle? Alrighty. That takes care of our burrs. Gonna chase these threads. Some of those bolts were not real happy. This middle bottom one, the bolt actually broke off in it. Don't think I'm gonna worry about it. We're just gonna send it. So we have our handy dandy box of loom. I'm gonna try to put this inside that hole, wrap it internally, and then also put it around the wire as it goes through the hole. I don't want any chafing. That'll go through there. I don't even know if we're gonna need to worry about anything else. I think that's pretty good shape. Now we're happy with where this is. I'm gonna crank this guy down tight. And I'm gonna chop this off. We'll leave ourselves a little bit of leeway. Side cutters do this. Oh, side cutters sure will do this. Now we're ready to pin this guy onto its forever home over there on our throttle. Alrighty, that's in. I'm gonna put a little bit of never seize on our bolts. Get to be the Tin Man right from the start. Chasing those threads made a heck of a difference on that. Cable's all good. Well, we'll have to look at that from the top side. How we actually want to run that cable up. I'm just coming up this hole that already existed here by the LMI. And then I'll plug in there. So we're also going to need to mount this box down to the dash. I haven't done that yet. It's still just kind of sitting here. We also need to drill, bolt the brackets on for these servos. Let's jump onto that project. So if we measure where this mark is and this mark is, draw a nice straight line on each one of these. We'll just take the angle grinder, chop that off. That way this guy will fit up in here properly. Right now this corner is kind of running into this. Let's see what we got. Ooh, so sweet. Mount that right in there with the servos underneath. I think I'm going to mount the servos back on here, clamp it like we did with the plastic one, make sure it all moves like it should. Man, didn't even have to bust out the die grinder. That's a good sign. I think we want to not have the flat washers because these are locking flange nuts. Something I think we're going to get into here is having to bend this all thread, kind of like a banana shaped package, to allow it to clear that servo. I think was part of our longer flange plan here. I think we're still going to end up needing our little reinforcement tab-a-rooney here. I haven't drawn or ordered anything in that department yet. Maybe we're going to have to lower this back down kind of more where the plastic mock-up was. I added 1.5 inches to the length of this because I was trying to make more leg room. And I do think the leg room looks a lot better. Just going to kind of have to do one of those maneuvers. Yeah, the leg room is definitely better than what we had. So it's just a matter of how can we make this connection happen. We'll figure it out one way or another. It's just not enough room for everything you want because your hand has to be able to turn the steering wheel. We're about as tight on that as we could possibly be. So I'm wondering, do we need all that travel for this to work effectively? So I'm going to fire it up and see how fast it goes at different travels. Basically from there it's going the same speed as going here. Right there. So there's definitely some deadband in it. I guess the moral of that story is if we can do a little bend in here, a little other bend in here, I think we can make this work. Not 100% sure yet, but it's possible. So in an effort to try to slide the servos down, make a better angle on things, I'm going to drill 4 new holes, slide them down, try that out. Drill presses are so much nicer than hand drills. It is slow. Mama. All right, we're bolted back in a little bit lower. Let's see if that helps our cause here. It's definitely not going to help our legroom cause. I can assure you of that. Still might need to bend a little camber action in these all threads. But yeah, that's definitely better. More better. I think if we bend this a little bit right over here, that'll help do what we need to do. Well, let's take the chance on heating this, bending a 90, see where we land. So we have a very scientifically calculated angle of about that much. Let's see how it works. So I'm happy with where the linkage is all laying out. Everything seems to be pretty happy. We're going to need to add some support. I'm thinking I can catch this bolt and just tie right into here. No big deal, to give it a little extra shaky reduction. But I'm going to take our center punch, hammer, mark the holes down here in the dash, get them drilled through, and bolt it on. Be a little better than our sweet C-clamp setup here. I really need to get a set of transfer punches. So we got the servos all hooked up. I'm gonna try to start this thing and see if it'll work. I kind of have a concern because the LMI hasn't been turning on when I fire up the key with the remote switch. So I don't know if we're getting power. There's kind of like 2 ignition wires coming off the key switch, so we may need to jump it, something. Maybe we got too much current for the circuit breaker. I don't know. But let's try her out and see what happens. Yeah, the LMI is keeping the hook from going up, but it can go down. Apparently it will load the engine up. See if our throttle's still working. Oh, we got throttle. A little touchy. Somebody's got to get power on that LMI so we can lower the hook, or raise the hook. Yeah, we can't raise it right now. So this is the issue I'm talking about. The LMI works with the key switch down here, but if I turn the key off, the LMI's off, and turn my remote override switches on, we're getting power there. But when we release the e-stop, and that's when it powers the dash on and everything, but we're not powering on the LMI. So something's going on there. Let me try to figure out what we have going on wiring wise. So this wire here is the LMI. You can hit it on the power and it works. So we have 2 ignition contacts off this key switch, and when the key switch is off, they're isolated. So all I'm going to do is move it over here with all our other friends on this terminal, which the remote control can power as well. So I've gone ahead and pulled this whole plate off the crane because there was no way for me to get my hand back in there to hold the nuts or even get a C-clamp to hold this bracket. I measured from this edge to here and looked at the difference of what I put that versus the notch where it's cut back here. And I did the same thing with this hole. Basically, we just moved it over 1/8 of an inch from where this line is. Held that up there. I've gone ahead, marked it, and then center punched our 3 holes where those need to go. Let's get this drilled out, and then I'm going to mount this on, and then we're going to figure out how we can tack the nuts onto the back side. That way we could take these off, put the plate back on, and then we can just screw these on easily from the outside because the nuts are already attached. Let's get these nuts tacked onto this plate. I kind of forgot I'm out of argon right now, so good old 6011 it is. For as terribly dirty, painted, everything else that I didn't clean up at all, I think stick was the right choice. Let that cool off, but then we can knock these stainless brackets back off and put the plate back on the crane. So one of the first things that needs to happen to get this thing to run on gasoline is to change out the choke cable, because the choke that's in it is very stuck. Another thing I want to point out, this ether injection is not a switch. As a lot of people have been telling me, it's already got ether. It doesn't have ether. This could have had a 4BT Cummins in it as a factory option. Then it would have had the ether mode. But for gasoline, propane, shouldn't really need ether. So I'm going to change out this choke cable. I don't even know if I'm going to hook up the backside, but we have the front plate off, this dash plate off. Now's the time to put this new choke cable in. Much easier. Got our bottom plate mounted back in. Mounted the dual servo setup that I had assembled on the right side now. We'll put the other one together for the left. Let's get them tightened up. I was looking here, I think we're gonna have to heat the gear shift with the torch, bend it back a little bit because, well, yeah, I was concerned about that earlier. So, fourth gear is pretty much what you need to be out of the way of the servo. Well, this thing's so rigged up. So we have one shiny new servo that I had to wait on from China because I took the other one apart incorrectly. As you guys saw, I got a little happy with the gear puller. We got one new servo, and I like that they have going on with this one is it has like a spline drive, so we don't have to drill that hole that I did on the other ones. So really, this one's nicer. Kind of wish I had all of them like this one, but we don't. No big deal. And we're gonna make this happen. So I'm just slinging cotter pins in each one of these ends, and we're ready for a full test flight. So some of these levers are operating backwards of how I'd like them to. Basically, I want this thing to match the crane. We're gonna have to relabel it, but right now we have this as being the boom up and down, this as being the telly in and out. So I just flip them to where they're plugged in over there on the receiver. But every single one of these is working opposite direction of how you'd want it to. So my easiest solution to that is I've taken the remote apart here, and all I'm doing is unscrewing them and flipping them over. And it's loose. Pop that out. Give her the old 180 package. Put her back. This is my low-tech solution. See, there's nothing very fancy about this remote. It's like the Harbor Freight version. And then the bottom's held together with these socket head cap screws. And that's all there is to it. Got our handy dandy tie spuds here. I mainly want to keep these cables from getting pinched and hurt over time. So this guy I plan on running straight down there. That way when this lever comes down, can't hit that wire. This one, same thing, we'll run it over here. That way when that lever comes down, can't hit that one. These style adhesive pads seem to work pretty well on the clean stainless like this. They don't do well on a lot of plastics like our HDPE that I've mocked these up with. They don't last. We ended up having to move to ones you screw on for that. That's like that. That'll be perfect. So I'm going to run these down neatly. I think I'll run a little bit of loom around this so it doesn't get cut on this edge. Stick some more tie spuds. Neatly run this up, and that'll take care of the remote control package. These are called flush trim cutters. Basically, they're flat on this side. All the bevel is on this side of them. This prevents you from having those tiny little jaggers on your zip ties when you use side cutters that you would end up with. Highly recommend them. So that's all of our wire routing completed. happy with how that all turned out. Let's fire it up. That's doing what we want. Now you can see these actually line up. In the same direction. Boom up, boom down. I think we are all good to go. That's our telescope in, telescope out. Let's try her out. Close our little operator in there. A little bit of throttle. It's alive! Can we get a third function in here? Ooh, easy, easy, easy. Not too block it. I think 3 functions might be a bit much for the crane and me, but we'll get it over there. See if we can throttle her back a little bit here. Swing over nice and easy. Oh, catch our load. So once the hook swings out, you're going to swing over it to catch it. That's what stops it from swinging when you do that. If you inevitably swing it. The no feel of this is a little harder to get used to on not being jerky. Take a little bit of getting used to. Raise her down. Get her hooked up. Ha ha! How sweet is that? Set it back down. You can definitely see the boom flex take out, like guys were telling me online about watching that you boom down if you're uptight on the ceiling. basically the fishing pole effect here, which we can boom down. I don't know if I could boom down as smoothly. You can try. We're better off to hoist. You can control that real nicely. And there she is. And we can shut her down. Well, guys, thanks for watching this marathon of a video as it turned out, but we now have us a remote controlled T-Rex. Basically like having a remote controlled crane on Christmas as a kid, just got a little bit bigger. Matt and I were saying he needs to, remote control his Grove. That would be a really slick remote control project, but this is a good place to start. First time I've ever installed a remote control or anything on a crane, so that was a fun learning experience. So the big takeaways in this project were, like every project I seem to get into, it took way longer than I thought. It wasn't overly complicated, but it wasn't really simple. There's a lot of little parts, pieces to make this all function properly. I don't like how much legroom we lost, but there's really no great solution for that. As I said earlier, if we ran levers off the bottom and like micro control cables, something like that, it would potentially help the legroom area, but now you have a whole new set of problems in mounting the servos, pushing on the micro control cables. The micro control cables with age, I feel, always get stiff. Think of a PTO cable in a dump truck, something like that. They're never nice and smooth after the first year, and this thing is going to do a lot of sitting. I wanted to put the receiver inside the cab for the reason of being outside, being in the elements. I didn't want that box out in the rain. I figured the more protection we give it, the better life we're going to have out of it. So that's the reason I jammed it all in the cab. Getting power out of the ignition switch, no big deal. We pretty much made that bypass switch, so the ignition switch and the remote control are in parallel. Either one can turn everything on and off. I did that to reduce battery draw, was my theory. When you hit the E-stop, it's basically turning the key off. If you had it with it, you'd have to have the key on, then key off. You could do it many different ways. That's how I chose to do it. So, thank you guys for watching. This was a fun project. I think the T-Rex with its remote control is going to be a great addition. We'll get to use it on plenty of things, starting here soon on the Mini Mac. So, thanks for watching. I'm Sam with Scrappy Industries. We'll catch you on the next one. Woohoo! Cool! Cool! Shut her down.